So we're going to look at integers, and in integers, we saying that integers are whole numbers, whether positive or negative or a zero. And so assuming you defining an integer, you could say maybe the name of the integer. You say, assuming the name of the variable is a, and then you use equal to sign and then the value. So basically this line, this is what it means. It's just saying that I'm creating a container called A. So the label is A. And in this container, we're going to put something inside it, and that value is 5. And so basically in this line where we have A equal 5, all we did was we created a container and we labeled it A, and then we put in a value 5 in there. And this is what this line is. The second line, which is that, is going to be doing something like this, creating a container, and that container is going to be labeled as B. And once it's labeled as B,
each program has one container.
So the third container is saying, or the third line is saying, create another container, which is a variable, call it C, and put a value 0 in there. And so basically we've created 3 containers in that script, assuming the script is, or the Python program is having only 3 lines. So A equal 5, B equal -33, and C equals 0. This is what the Python file is. So basically, in terms of memory allocation, what we've done is this. The first one, when we created a container, which is the variable A, is just giving a space in memory called A, and then we put in 5 there. The second one is creating another space in memory, calling it B and putting -33 there. And the third one, which is C, is creating a space in memory, calling it C and puts in the value 0 there. And so once we have the variables created, we could use it for something, and that's something that we'll be looking at in the videos. All right, so the next one is a float, similar to what we had for the integers. With a float, what you're doing is you trying to create another container. This time around, we're calling it D. So basically call it D, and then it's also going to be a space in memory. But mostly integers are smaller in terms of size than floats, in terms of the allocation of space in memory, but don't worry about that. And we call in this one D, and this is 5.67. That's what we've done here. So in terms of containers, we just say D, and then we put in 5.67 in there. The second one is E. And so with E, we're saying that we put in a value in there, and that value is -33.2. So I just create a space in there. I'll call it E, and I'll say -33.2. This is exactly what we've done here. The last one is creating a container called F, and again, the same process. And then we've done 0.01, 0.01, so F 0.01. And this is how floats are. All right. Now we already saw what Boolean is. Like I said, Boolean is used for specifying whether a value or a statement is true or false. So assuming I want to, so for a statement like the interface is on. So I'll say it's on. If the interface is not on, then it means that statement is false. But if the interface is on, then it means that that statement is true. So basically, when we're going to be doing interfaces and all that, you could do that as well, but it depends on the language we use, the type of scripting we're doing. You could do that as well, on, off, and all that. Then we have strings. We saw strings as well. So strings is a very special data type because strings is just, as its name says, it's a string of characters, meaning it can have more than one character. So the word London It's not just one item. It means that we're creating so many spaces in memory. So like there's and this. So basically with strings, we're saying that create some space in memory depending on how many characters you have. 1, 2, 3, 4, 5, 6. So it means we're creating 6 spaces in memory. 1, 2, 3, 4, 5, 6. But what happens is that once you write this, it's going to start from the D will start from here. And because it will count the number of characters you have in there and it will allocate the number of boxes. So it knows that D will end here. So D starts here and D ends here, just because of the number of characters that we place in there in Python. That's basically what is happening. Now, one funny thing about strings is that though we're saying that D is starting from somewhere and ending somewhere, what we're also doing is that we're creating positions for all the characters. So the first character in most programming language, the first space in a string is given the position 0. We don't start counting from 1. The second one is giving position 1. We'll see that, so don't worry. This is position 2, 3, 4, and 5. And so assuming somebody wants only the first character, they'll say, if you go to D, the container called D, I just want the first character. So I'll say 0. And that will bring out, when you do this, it will bring out L. If we go to position 1, it's going to bring out O. If we go to D position 2, it's going to bring out the value N in that order. If you go to position 3, so which is actually position 4. So we call positions indexes. So index 4, index 3 means the 4th position, and that will bring out the value D. So we'll be looking at all these things practically in a few seconds. And this is just a typical example of how strings behave. So because strings can have random characters, and let's say assuming it can have a name as well, and you can have special cases where you can change the value. Even though we wrote it in lower cases, we're going to have a scenario where you can also change that into upper cases. These things, they come with the language. So with time, you get used to it, or you get to know how it's used. Today's session is just trying to help you understand what data types are. And again, understand that some data types can be manipulated in a particular way. So we'll be seeing some practical demonstration now. So
one doubt in that.
Yeah.
Like we said, like